SharkNet provides a set of high-performance computing resources that are freely available to Canadian researchers and their international collaborators. These resources take the form of HPC hardware, software, and expert support, all put into place to facilitate computationally intensive research. This SharkNet New User Seminar is designed to get our newest members up and running with these systems as quickly as possible. The seminar is in 3 parts, beginning with the Getting Started with SharkNet presentation. It goes over an overview of these systems, then a tour of the online resources and documentation, and a demonstration of using these systems from the command line. Getting Started with SharkNet. What is SharkNet? It's a consortium of 18 Ontario institutions providing advanced computing resources and support. It stands for the Shared Hierarchical Academic Research Computing Network. It's a member of Compute Canada, and there's over 3,000 Canadians and international users on these systems. It provides many CPU cores for compute, as well as GPUs and advanced networking. In order to get started with these resources, you want to know about the online documentation and support. The SharkNet website provides extensive information about the system, software, and general help. General documentation, there's a user-editable wiki page, is found in the web portal menu at Help and the Help wiki. The knowledge base, I can expand it if you ask questions, is a set of information that's extensive and is built on Ask Questions in our ticket system. There are tutorials and detailed documentation on systems and software as well. You can also check on system status. System notice history, present status, and statistics are available in the web portal under the Facilities page. This is a good place to go to keep track of how systems are working and even explore what sort of wait times might be there in certain queues. System notices are also available via email, posts, or an RSS. You can manage the lists that your account is on in terms of getting updates, notices, or system notices by managing your account and selecting, for example, specific email lists for specific systems that you're working on or softwares that you're working with. In terms of problems, you can search in the web portal will return relevant problem tickets. We have a problem ticket system, and you can search the content of these through the web portal. And the best ways of getting help, if you can't find solutions to your problems on the web portal, is by submitting a problem to the ticket system. You can submit problem tickets by going to Help and Problems in the web portal. This will bring you to the interface where you can add basic information about the issue you're having, as well as the system you're running on, and specific information, for example, what it was that you tried to execute, the errors that were returned, as well as more specific things like the actual job numbers of those things and the times that they ran. Once you submit this information, this will go into our ticket system, and the staff will assign it to the best qualified person. Some essentials about the computing environment. We have several compute systems, clusters, including GPU, as well as visualization systems. The operating systems are typically Linux, mainly CentOS, as well as some others, and we support several languages, including Fortran and things like MATLAB and Python. Of course, on these clusters, we support parallel development, including MPI, OpenMP, CUDA, etc. And there are several software packages that are available on our systems and maintained by our staff. You can select pre-built and configured software, as well as versions with the module command. It is also possible to install your own software within your environment, and that is something that our staff can help with. In terms of actually performing the compute of production level work, most of this is done through batch scheduling. We have the SQ resource, the SharkNet Unified Batch Execution Environment. Some essentials in terms of access to SharkNet. Most SharkNet systems are only accessible through Secure Shell, SSH, and we recommend authenticating using an SSH key agent, which is the most efficient as well as secure way of doing this. You can see the SSH page in our Help Wiki details. In terms of performing compute on these systems, you'll need to get data into the file systems that are accessible to the compute resources, and file transfer programs are typically Unix-based, for example, using SCP, FTP, or rsync. Typical. If you're on a Windows machine, we recommend clients such as MobaXterm. PuTTY and WinSCP are also valuable. Some essentials in terms of the file system basics. There are different file systems on our clusters where you can keep different types of files. The properties of these file systems really define what they are used for. The main ones here are home, work, and scratch. And their properties are defined by their quota, that is the size of the information of the data that can be on these systems. The expiry, that is the duration these files can be on the systems, and the access, that is, where can you see these systems from. So getting started with home, the quota is currently 10 gigabytes. There is no expiry on the files folders in this area, and the access is unified. This means that regardless of what system you log into, for example, if you log into Orca or Kraken, and you go to your home directory, you'll see the identical files there. These files can be here for an indeterminate amount of time, and it's capped at 10 gigs. This 10 gig quota is a hard quota. That is, if you try and write files there beyond the 10 gigs, you'll get file errors. The write errors because there's basically no space left for you to write. Given these properties, the purpose is really to keep source files and small configuration files. Importantly, this is the one system that is backed up regularly by our systems. The work directory has a larger quota, really 1 terabyte of storage, also has no expiry, and is unified on most systems. Based on these properties, this is a good place to keep your active data files. These are the data files that your compute will be accessing, and as well as where they'll be writing the output. It has the automated and convenient mount, and is accessible, of course, from almost all systems. In this case, the 1 terabyte quota is a soft quota. That is, if you have jobs running that are writing to this directory, and those jobs write files that exceed the 1 terabyte storage limit, these jobs will not fail. They will continue to be allowed to write beyond the 1 terabyte, but if there is more than 1 terabyte in these systems for too long, and you stay in the over quota status, you'll be restricted from getting new jobs into the running state. As you will be informed that you're in the over quota status, your account will be restricted, and new jobs that you submit to the scheduler will not get to the running state. To resolve that, it's just a matter of getting your storage back down below 1 terabyte in your works folder. The Scratch file system has no quota in terms of the size of storage, but has an expiry of 2 months. Also, the access is per cluster. Now, although there is no size quota, of course, there are hardware limits on how much data can actually be stored in this area. This file system can become full by all users, and then errors will start to occur if jobs are sending files there. So it's important to use this as a temporary space. And accordingly, we put a 2-month expiry on files in this file system. This means that at the end of the 2 months, you'll get a warning that on the Sunday, the jobs that are older, or the files that are older than this, will be automatically deleted from the file system. Access to Scratch is per cluster. This is to say that if you log into Orca and go to your Scratch folder, you'll see one set of files. And if you go into another system like Kraken and go to your Scratch folder, you'll see a different set of files. Based on these properties, the purpose of this file system is really for temporary files for doing things like checkpoints. You may also find performance increases here as they're local to the compute. Some useful storage-related commands are quota. Executing the quota command from your account will tell you how much storage you have in the relevant file systems and where you are relative to going into the over quota status. Do lists the usage within a directory. Besides having compute nodes, we also have a data transfer node, the dtn.sharknet.ca. This system sees the internet in most SharkNet file systems, and importantly has no CPU time limit. This system is very useful for transferring large data files. That is, it sees the per cluster, many of the per cluster access systems, file systems, and the internet, and can be used to transfer data at large scales without the concern of running out of time. So storage limits and enforcement. Scratch file systems have limited shared storage space. As I mentioned before, although there is no quota on the storage space, the entire system can become full and cause errors on jobs that are running. There's also problems if you have over 1 million files within a directory, and given the effects on performance, we restrict this that if you have over 1 million files, you'll not be able to start new jobs as you'll go into the over quota status. Some essentials of the main SharkNet systems. SharkNet has several systems that you can navigate, or properties from the portal and the systems page and facilities. But here is a basic overview. The very popular system Orca has several thousand cores and has target jobs. There's large MPI and threaded. Also, the Orca system has development nodes. Development nodes are very useful in terms of getting jobs started. That is, when you're doing production work, you'll be submitting large jobs to the scheduler, and they'll get into the resources whenever there is available compute and memory. But if you wanted to test how the jobs are running and do profiling, what you can do is you can log into a development node and use the programs interactively at the command line. In this way, you know that the jobs will run exactly like they will once they get submitted to nodes by the scheduler. There's also SAW, which has over 2,000 compute cores. It's good for medium to large MPI. It also has development nodes. The Requin system is a bit smaller and has a test queue. So another level of being able to profile jobs is, rather than going into a development node and using the code interactively, Requin provides a test queue. That is, you can submit a job to the scheduler with the commands that you would like it to execute with, and then this test queue will jump the regular queue and get your jobs into the running state as quickly as possible. This will allow you to make sure that your submission command is working properly and that the job actually starts quickly. Of course, submitting to the test queue has ramifications in terms of your priority in queuing normal jobs, and these jobs can only run for an hour. So this is really just to test that the way that you're submitting the jobs will get started. Kraken is a large heterogeneous system. It's particularly good for serial farming and small to medium MPI threaded jobs. It also has several development nodes. And then there is Monk, which provides some GPU optimization. These different systems have different properties, and by that are better for certain kinds of work that you might be doing. So you want to know which system should I use, and you can search this on our portal to provide some information about which system you're most likely to get your jobs working on most efficiently. Beyond these systems that we've described here, there are many other different types of systems contributed in specialty systems, including visualization systems. Some essentials in terms of managing jobs with SQ. As we mentioned a couple times, a lot of the work that you'll be doing for production research will be done by submitting jobs to be handled by the scheduler and executed in an unsupervised way on the compute nodes. So all significant work is submitted to the system as a job. Jobs are run in batch mode by a job scheduling system. It enforces policies to promote fair and efficient use. These jobs are submitted using sq_sub command. As an example, you would log into a system and write sq_sub-r, enter the expected runtime, -o, the log file that you would like to write this to, some options, the program you want to run, and its arguments. The required options are the -r for runtime and -o for the output file. The output file will collect the standard output from your program and then save it to a file. Runtime is the estimated runtime for the job. For example, -r1d is that you are giving this job 1 day to run. After runtime is exceeded, your estimate submitted to -r, the job is killed, and you have a maximum of 7 days for this input. The runtime input is an important piece of information to include and have an accurate estimate, because this is what the scheduler uses to manage which jobs run. For parallel jobs, one has to also specify to the -q command. For example, if it's an MPI job, -q MPI, or for threaded jobs, q threaded, as well as the number of CPUs in this case, or n the number. Once you have jobs in the queue, you can use sq_jobs to list the status of submitted jobs, whether they're queued, running, or complete. And if for any reason you have to kill jobs that have been submitted in any state, you can use the sq_kill command. There are certification limits and development options. Your user certification level determines the job size and runtime limits. Whenever you first get an account with SharkNet before completing the quiz that is available after attending a new user seminar, you have access to 8 CPUs in 24 hours. Once you attend a new user seminar and complete the quiz, you go to level 1, where you have access to 256 CPUs and a maximum runtime of 1 week per job. If you need resources beyond this limit, you can contact us to see what options are available. For example, the resource allocation competitions. There are multiple ways to develop work at SharkNet. Whenever you log into a system, you go to the cluster's login node, and in here you can run small tasks. Of course, this is where all users who are logging into a system go. So this is just for small tasks, for editing text files, for doing some file management, etc. There is the test queue, which we talked about briefly earlier, that is only available now in Requin. It preempts the normal queue. You can only submit 1 job per user at a time, and that job has a maximum of 1 hour runtime. As I mentioned earlier, a valuable resource is the cluster development nodes. They are available on Kraken, Saw, Orca, and Monk. You can log into these nodes to also include visualization by ssh-Y user@orca, etc.sharknet.ca, and then log in from there using SSH to a development node. And then you can work interactively with the system and test jobs that you would like later to submit for production to the scheduler. There are also visualization workstations where you can log in and run programs interactively for visualization. Some common mistakes to avoid: do not run significant programs on login nodes or directly on compute nodes. Really, for most of the production work you'll be doing, you'll want to submit them as jobs or use the development nodes in some cases. Do not specify a maximum runtime of 7 days or more memory that is required for your programs. You want to pick an appropriate value, for example, 150% of the measured or expected runtime or memory per process. This is very information and can affect how long your jobs are in the queue, as well as how efficient the scheduler is working. Do not run unoptimized code. We have information on profiling testing efficiency, scaling for parallel programs, and this is something that you can ask for help from our support staff. Of course, the system can only run as efficiently as the code that is running on it. Do not create millions of tiny files or large amounts of uncompressed, for example, ASCII output. There are many ways to aggregate files with tar or dar, or use binary or compressed file formats. If you have questions or concerns, the easiest way to access support staff is via help@sharknet.ca. Of course, this is a recording of the seminar. Now for a tour of the web resources at www.sharknet.ca, where you'll get to a login page where you can either register or sign in as your user. Once you sign in as a user, you'll be typically directed to your usage or activity page. Here you can find information about your jobs that have been running and a recent history of it. As a brand new user who hasn't completed the certification quiz, you can find the certification quiz at the top of the menu up in the upper left-hand corner. Once you complete this quiz successfully, you'll be up to level 1, and the resources that you have access to will be increased. You can manage your account in My Account and settings, details. You can change your password, etc., as well as access files, the policy files. You want to be familiar with all of these, for example, the acceptable use policy document, the scheduling policy, etc. There are plenty of resources for monitoring how the systems are running from within the portal, as well as access to documentation about the systems and software. In Facilities, you can go to Performance and check on the current performance, and you can see an overview of the systems and how much work is currently running on them. You can also get rundowns of information of the number of jobs, as well as some estimates of the wait times and systems for specific types of jobs. In Facilities and Systems, you can see a rundown of all of the systems that are available, the core systems, and by clicking on these, you can go to its documentation, where you get an overview of how the nodes are organized, as well as the resources that are available on them. You also get the software available for those systems, and by clicking on any one of these, you can go to that software's documentation. Importantly, you can also find the recent system notices on this page. These system notices also go out to the email lists to those users who are signed up for that list for this system. At the bottom of this page, you can find the visualization systems. From here, you can actually log in directly to one of these systems to start a visualization system. For example, if I click here, it'll bring me here, and I can sign into this system and start using it. The software page lists all of the software that is maintained and supported on our systems by our staff, applications, commercial compilers, etc. beyond the software that is supported and maintained by our staff on our systems, it's also possible to install your own software within your user environment on the systems. When staff helps users install the system, these softwares within their environment on the systems, we document that software here on this page. And you can find information here about how those softwares are installed on the system, going here and finding instructions for that installation within the user space. Of course, the news and events, you can go to the calendar to find events that are coming up that are organized by SharkNet. In particular, you can notice every 2 weeks we have a general interest seminar that's put on by our staff that talks for an hour about specific issues on high-performance computing and research computing. Within the help item, there's the FAQ knowledge base. This is a lot of information from getting started to tackling specific tasks on the system. A lot of this is made up by the interactions that we have with the ticket system. There's also the Help Wiki. In the Help Wiki, there's information about getting started, some hardware, programming help, visualization, as well as a list of online seminars. Here you can find all kinds of recordings of seminars that have been put on and recorded. Within the Help menu under Problems, you can click on the Submit button, and this will bring you to the ticket submission interface. Entering information here and a description of the issue, and then submitting it will go directly to our support staff, and then we try and resolve this and get back to the user within the day. Then in the About Us, in the Contacts and Directory, if you want to find support from a specific support staff, you can find our listings here, as well as some of our specializations. Moving on to the terminal demonstration of using some SharkNet resources, I'm just going to bring up some common and basic commands that we typically use when you're getting started while transitioning from working on a local machine over to the remote compute resources at SharkNet. So here I have my terminal open and I'm on my local machine in my home directory. And I'm just going to go into a folder that I have some example stuff in. So I have this folder, the SharkNet SNNU demo, SharkNet new user demo. Now, what I want to do is I want to take this folder from my local computer and send it over to the cluster so that we can load some files, look at what's in them and compile them. So to do that, I'm going to use scp-r, recursively send this folder to my login on Kraken and put it in my home directory. Let me see here, I transfer it over. And then now what I can do is I will go and log into that system where I put the folder in my home directory using ssh j.kraken.sharknet.ca. And there we have. I log into the system. This has put me in the login node at Kraken. And I'm in my home directory, where I can use lsl to list the folders, and we can see somewhere here that the SharkNet new user demo folder is here. So I'll change the directory, list what's in here, and I see that there's this little file called the snhw SharkNet Hello World C. So what I can do from here is I can open this program source file, and take a look at what it does. It's a basic hello world. And what I can do with this file is I can, while I'm in my login, I can compile it to run using CC compiler. I'm going to compile this file and then output it to this executable. Run that. So, and then we can see now that the executable is here. So here from the login node, I can then just start running these. So we've basically done some little commands. We've opened text files. We've transferred data. And we can just run this basic function here in the login node. And then we see that it just pastes the standard output to the terminal here. So execute in the login node on SharkNet where it was compiled. Now, what we want to do is these jobs become bigger, and any substantial work shouldn't be done in the login node here, but actually submitted as a job to the scheduler. So in order to, instead of running this right where I did to get the standard output here in the terminal, I can submit it as a job using the sqsub function. I'll just paste this. So this is the SharkNet qsub command specifying a runtime of 5 minutes. And instead of putting the standard output to the terminal, we're sending the output to a file called snhw.out. And then this is the function that I'm going to execute, the executable that we just compiled. Enter, and get a warning. We didn't specify the memory that this was going to use, and it defaulted to 2 gigs. There's more, but this will run quickly. Now that the job has been submitted, the job ID is this value here, we can then query our jobs that are in the scheduler. Typing sqjobs, we see that we have this one job, and it's a serial job that is now in the done state. In D state means that it's already gone through the queue state and the run state and is completed. And we get some summary of the resources here. And then what we can do is we can check this folder again, and we see that it generated the new output, snhw.out. Now what we can do is we can take a look at this file, SharkNet world.out, and see that the standard output that we originally saw when we just executed the program from the login node at the terminal is placed at the top of this log file. This is where the standard output goes. And then we see that it terminates with a SharkNet job epilogue. This gives information about the actual resources that were used up during the execution of this program. And this can be used to make accurate estimates of how you want to run similar jobs in the future. Now, let's just repeat those things now and see what it looks like to run an MPI job on multiple processors. So let's say you find a great piece of code that's MPI. Let's put it here. Let's see. Here's a hello world example for MPI. Excuse me. What we can do is build a new file. Let's see. SharkNet hello world, but now MPI. Grab this. Sorry. Put this in here, and then save this file. Now we can see that we just generated the SharkNet hello world MPI source. And then from here, we can compile it as MPI in the login node. Now we have the executable, SharkNet hello world MPI. And then to submit this as a job on multiple cores, we can use this function. We're still using sqsub. The runtime is still 5 minutes. The output, of the standard output, will go to snhw.mpi.out. Now we're specifying that the queue is MPI and the number of cores is 4. Then the job to execute the actual program is this SharkNet Hello World MPI. Enter. And we get a warning again that we didn't specify any memory, so it's assuming 2 gigs, and then we get the job ID. Now using SQJobs, we see that now we have another job listed. It was not serial this time, but MPI, and it is already in the done state and used 4 cores. And then these are the specific resources that it used. And it's been in this done state for 6 seconds when we called this job. Now if we go back to our directory, we can see that SharkNet Hello World MPI.out was generated. And then we can take a look at this one. So here we see now that it's running MPI, there were 4 simultaneous versions of the Hello World, and then we get the SharkNet job epilogue in the output. So that's a basic rundown of the commands that are typically used to transfer data over to SharkNet file systems, doing a bit of management within the login node, compiling, executing in the login node, and then submitting the jobs, both as serial and MPI. So going back to the overview, this is really the end of the SharkNet New User Seminar. Of course, the easiest way to get in contact with any of the SharkNet staff is to use help@sharknet.ca.